Heat energy flow, yeah.
Can sir.
Yes, sir.
Okay, so I think we also discussed before that for the energy flow, mass and energy are very much interrelated. From mass, energy would appear, and in some extent, from energy, mass would appear. But that is different. You know that synthesis of chemical synthesis, yeah, that how they produce huge or enormous type of organic foil or something, that is a artificial system for energy to mass conversion. But in the outermost sphere or in quantum level, energy annihilation also produce mass. That is different thing. And in our engineering world or our realistic world, we do to transfer from mass to energy. That huge amount of energy we use our daily life, different purposes. Say our food, we use chemical energy from food, and that is also on type of conversion of mass to energy. Say we use petroleum, we use our electrical system, we use our um, uh, how to say the other energy means they may say storage energy or say solar energy, say windmill, the hydro energy, all sort of energy we use. Actually, it is for the purpose of what? Purpose of our daily life work, or we do something from electrical energy to ultimate the end work is a mechanical, or some extent it is actually other types of a display. So think that the different activities, say as electrical engineering, the huge part of our work actually dealings with the electrical energy generation, its transmission and its distribution. But distribution for what purpose? We use it at the user end, say for a rotating fan, for air conditioning, for a TV, for freezer, for a computer, for light. All sort of energy actually is conversion from electrical energy. But at the beginning of our energy generation, if you think, it is actually from different sort of mass is there. Petroleum itself a mass, coal itself a mass, gas itself a mass, then hydropower also itself a water mass, and then the wind also a mass. Then how to say the solar energy also electromechanical is the terms of light energy transfer into electrical. So think that all the system, that transformation of energy, actually some means our daily or our earth, it is converting from mass to energy, and such energy we are applying for different purpose. Say for the industry, we are using say for industrial development, now we are using robot. So how the robot drive? The robot also drive through electricity. So we are applying electricity, and at the end we are doing the mechanical work. Such way, the energy transformation is everywhere, but our consideration is not only energy transformation. In the process of energy transformation, how heat energy influence, that is also the part of study of thermodynamics. So here the consideration is heat energy flow, because I don't know whether you know or not, because for the heat thermal process, that most of the world electricity still generates, say more or less, developed world almost 40%, and developing world almost 70%, or more than that 80%. Electricity generated from heat thermal process. Heat thermal means we combust several types of materials, say petroleum, say gas, say coal, and it burn actually the water to boil it, and then the water vapor flow very forcefully inside the uh, control system of volume system, and ultimately it actually try to rotate the turbine. The turbine is coupled with the generator and it produces the electricity. This is very fundamental and very beginning concept of the electricity generation through heat thermal process. Then the other process now started, as I discussed, that the hydropower, then windmill, solar photovoltaic, asasa, the nuclear is different form. Nuclear also a form of the the heat thermal process, but here we use coal, uh, petroleum and gas as heat thermal process. But in case of nuclear, we use nuclear reactive power. That means nuclear uranium or something that radioactives to generate huge heat. That is also do that heat to flow through the control system, and it ultimately rotate the turbine that couple with the generator, and the electricity generates. So think that the such process actually who is the carrier of the heat energy here? Whatever we are talking about, say conversion of coal, conversion of petroleum, conversion of gas, conversion of nuclear uh, energy, all sort of energy actually we are producing by burning. Actually, we are actually transferring the energy from materials to electricity as a carrier of energy. That is the water vapor, actually the carrier of energy. Why water? That we'll discuss later. Because water can consume huge heat with minimize the temperature, because you know that water specific heat capacity is very high, so it can consume huge amount of heat maintaining minimum temperature. So that is heat is actually energy. No, temperature not energy. Yeah? Heat is energy. So it if it can consume huge heat, that means it can consume huge energy, and such energy flow will actually transfer through the fluid dynamics to mechanical system, rotator turning, and ultimately electricity generates. So such process we need to know that actually how it acts. This is very fundamental concept, but whatever we discussed in last lecture, it is some extent relating to the pure materials. Actually, pure means it means that how about it get gas constant to support the. Okay, just wait. I think someone is in the system asking. Okay, so in such process actually we carry the energy through water vapor or even water. So here you can see that water PVT status. PVT I think already you know. P stand for pressure, V stand for specific heat capacity. Oh, sorry. V stand for specific volume, yeah, and T stand for temperature. So here you can see that the different temperature actually how the water pressure and its specific volume is varied. Think that whenever temperature say 50 degrees Celsius, say pressure is 12.35 kilopascal, wherever the specific volume is 7.72 meter cube per kg. Whenever it raises say 143.6 degrees Celsius, the pressure rise some extent 400 kilopascal, and then you can see the temperature increase, pressure also increase. But what is actually happening there? It is reduced significantly the specific, the how to say that specific volume is reduced significantly from 7.72 to 0.46. Why? You have to think it fast, because whenever temperature rise, it is more than 100 degrees Celsius, so it is no more in liquid phase, it is in vapor phase. And not only that, it is also almost 4 times of the natural pressure. That means high pressure and high temperature, it flow through a certain system with minimized the specific volume. That means once you say that there is a minimized specific volume, it does mean that it is high fluidity stage, it is high volatile stage, it is high entropic stage, and it can support to energy flow, because it is no more in mass stage, it is actually in mass to energy level, mass to energy. Because whenever water itself is in a liquid form, it is in the mass form, but whenever water is applying heat, and it is make a egg vaporize, then it is in the entropic stage, and it is actually energy transferring stage. And such stage, definitely the specific volume should be less, because now the molecule of water is very less, but it is highly energetic to transfer energy, because it already in high temperature and high pressure to flow through a certain control system. Now it is raised, say, 250 degrees Celsius and pressure 500 degrees Celsius. It almost maintains similar. Think that it almost maintains similar. Here is the status. You have the saturated mixture, saturated vapor, superheated vapor. And if you fall down the temperature, say 110 degrees Celsius, and pressure also fall down, but it is no more in liquid phase. It is still in this phase, that it's compressed liquid, yeah, because you know that the amount of molecule inside the vapor is no much more as it is inside the water. So that's why here specific volume is getting lower. That means if you say you are vaporizing the water, but you are collecting the vapor, ultimately say it actually huge volume you are collecting the vapor, but whenever it condensed, ultimately the water is very minimum. That means if you consider volume per unit mass, it is very very minimum. That's why you can see here this scenario. So I think you understand that with if effect of temperature and pressure, how specific volume is varying. Because in our previous lecture we discussed it that the three variables, temperature, pressure and specific volume. So how temperature specific volume varying with temperature, how specific volume varying with pressure, it is in summarized form. Because before we discussed the last sorry that lecture that um, specific volume can vary with temperature, specific volume can vary with pressure. So here you can see the table that how it can show it, and that specific volume at low pressure and temperature while high, but whenever it raise the temperature and volume. So you know that the phase that does from liquid phase to mixer phase and the gaseous phase, three phase. Inside the boundary there is a mixer phase. Outside the boundary, right, it is truly vapor phase. Left side of the boundary, it is truly liquid phase. So the such phases, a specific volume actually from the initial solid phase is huge, whereas the final vapor phase is very minimum. That means it is actually varying with the application of either temperature or pressure, and it is considered as fluid water actually the carrier of energy or heat energy. So here heat flow PV concept, because the table here shows PVT, all the pressure, specific volume and temperature issue. So heat flow concept in PV, that means pressure and specific volume. So here you can see that there is a water 2 megapascal pressure 1 kg of water, and it is actually volume is 150 liter, 150 liter. So what does it mean? It's written in volume as 150 liter, its mass is 1 kg, its pressure is 2 megapascal. And you can see here a sign, Q is outside. Q means actual heat energy. So from this figure, what you can guess? What is the normal or very general concept? Q or heat energy is flowing outwards or towards the environment. What is the reason? The inside temperature is higher or lower than environmental temperature?
Higher.
Definitely higher, yeah, because there is no reason the heat energy flow outside with if it is lower than the environment temperature. Definitely it is higher. So how what we can do? We have to know or analyze the PV concept. How? We need to find the specific volume of the system. So specific volume means the volume per unit mass. Yeah. So volume per unit mass, what should be? Here volume is 150 liter, mass is 1 kg. So it should be what? Liter you have to transfer it in the density system for the volume gauge. So you can find it that the specific volume is actually volume per unit mass. The volume is 150 liter and mass is 1 kg. So you can simply write 150 liter per kg. But you have to make it actually in the volume, not liter, actually meter cube. Yeah. So what is the relationship between the um, uh, density and volume dynamics? That means liter, how to transfer to the meter cube? You should learn it first, yeah, because you know that for the 1 meter cube of water, it is actually 1000 liter. 1 meter cube of water is 1000 liter, whereas 1 meter cube of air, it is only 1 kg of air. Why? Because the air density and water density, you have to think it first, that how is actually air density and water density vary. If the air density actually almost 100 times less than the water density, so definitely 1000 lit 1 meter cube equal to 1000 liter water. 1 meter cube is equal to 1 kg air. So here 150 liter equivalent how much meter cube? You should learn it first. Then from this meter cube actually is a volume coordinate. Then you have to divide it with the 1 kg of mass. Then you will get the specific volume. Once you get the specific volume, you have here the initial P1 is 2 megapascal, and the temperature at P1, T1 is 390 degrees Celsius. And final pressure, temperature will fall to 100 degrees Celsius. That means initially at the chamber, it is now 390 degrees Celsius. But whenever it radiates heat, ultimately it is at the 100 degrees Celsius. So it definitely losing heat, yeah, because transferring heat from 900 temperature from 390 to 100 degrees Celsius. So if so, it raised at the final temperature 100 degrees Celsius. Then how about the pressure? Final pressure, how we can get it? So think that PVT relations, PVT, how they are related. Because previous lecture we discussed it, that the P1, V1, how relate to the P2, V2 or something. So in that case, it is P1, it is V1, it is T1. Say it is V2, V1, V2 is same because no volume change, it's a confined volume. It is T2, so definitely P2 should vary. So if we have the all other variable, then we can easily find the rest variables. And so we also can make a diagram in the PV system as a pressure specific volume diagram. And what should be? It should be definitely, say, initial P1, B1, T1 is the position 1. Then P2, B2, T2 should be position 2. So think that with the same specific volume, V1 equal to V2, one position and two position, the specific volume is written same. Because why? The volume is same, the mass is same. It does not change. Only changing is pressure and temperature. Pressure and temperature is varying. While temperature is falling, definitely pressure will fall. So this thing, that this is the variation. Here it is no more uh, clarified in the numerical stage, but you can calculate it. P1, V1, T1, P2, V2, T2, how actually it varies, and ultimately you will can get the P2. This P2 will satisfy this level, while P1 2 megapascal will satisfy this level. So definitely the pressure is falling due to falling temperature. Why? Because heat is following out. That means work is done by the system, not on the system. If heat energy flow inside, it is work done on the system. If heat energy flow outside, work is done by the system. So if heat energy flow outside, definitely the temperature, final temperature will fall, and it will raise 100 degrees Celsius from 900, 390 degrees Celsius, and in that situation, pressure must be fall, and the pressure should be go this. So this is the diagram. You know this diagram. I think I discussed the last lecture. This area is totally vapor, vapor phase. It is mixer phase, liquid and vapor mixer phase, and this one is liquid phase. So this phase actually transferring from a solid to vapor, and this is the phase transition area. Because such rising level P and V, it is actually processing the internal energy of water, and finally it follows this rule. So if you can plot the temperature variation graph, definitely the temperature variation should be follow this. This is the T1, this is T2. Definitely T1 is higher than T2. Why? How we can understand? Because for the constant specific volume, no more changing volume, that means pressure is falling, definitely temperature will fall. This is the concept, fundamental, how to say, the pure substance concept, that how pressure, temperature, and specific volume, they are interrelated in a system. While the system temperature is higher than environmental temperature, and that's why the energy is flowing from high temperature to low temperature. So think that it is both way follow the new thermodynamics rule, both in the energy flow, energy conversion from actually it is follow the second law of thermodynamics, that heat flow or energy flow from high temperature to low temperature region. I think I understand, yeah, because this is the phenomena how to analyze the heat flow through the carrier or the water, because water actually the carrier of heat. Even you know our environment, water actually the carrier of absorbing heat, because whatever we are doing, the activities in the earth, they are producing enormous amount of heat, but it is no more rising our environment temperature. Why? Because it is actually sucked by the water. That's why enough water, you know the smart city concept, yeah, enough water area, surface water area is required, enough plantation also required. That is very much fundamental for a smart city or very healthy life standards of the city based population. Country based no problem, country still has there are a lot of plants, lot of water resource, but in the city based area, to make it standardized of the human health or mental health, there must have required enough water, surface water, and also enough plantation. Why plantation? Plantation can provide enough oxygen and absorb carbon dioxide, that will mitigate the heating effect. At the same time, enough water also can absorb enough heat, that also can suppress the environment temperature. And that is the ideology of the green living standard or smart city. So I think understand this part. Now the different scenario. We'll go move to the second stage. The same thing, the PV, the pressure and specific volume concept. But here, what you can see, here is 10 kg of, say, it is 10 kg of fluid, say water or something, and the volume is 1.348 meter cube. So we can get it the definitely the specific volume, yeah. Volume per unit mass is the actually the specific volume, but it is different from previous scenario. Previous scenario, this temperature was very high, that's why the heat was flowing outside. But here now it is minus 40 degrees Celsius. What will be happen? Definitely the environmental energy will flow towards the inside the system, since it is no more adiabatic, no more isolated from environment. So definitely the environment 25 or 20 or 30 degrees Celsius, it is very much higher than the minus 40 degrees Celsius. So definitely the heat will flow from environment to here. So what will happen? Say here, you can consider again the specific volume by volume per unit mass. It is similar as before. It is actually, before it was in terms of liter, it can transfer to the meter cube. Now it is already in meter cube. So if you just put the meter cube and the mass, then you will get the specific volume, because it is confined area, no more change in the either materials or volume. So it is fixed for the initial and final stage. What is changing? So here the initial pressure is 50 kilopascal, P1, and T1 is given here 40 degrees Celsius minus, 40 degrees Celsius minus, and T2 ultimately is 65 degrees Celsius. So think that it is actually kept inside a certain high temperature system, that definitely huge amount of heat is flowing inside, and it raised the temperature from minus 40 to plus 40, 65. That means almost 105 degrees Celsius, rising the temperature inside the environment. So who is actually absorbing such temperature energy? Actually absorbing by the water. Yeah. So then here also the same thing. Then what would be the P2? The pressure should be what? So here pressure should be increased or decreased to rising the temperature, because from previous discussion, previous page discussion, I think you realize that low temperature definitely pressure should be high or low. For low temperature pressure must be low or high, because minus 40 degrees Celsius is very low compared to 65 degrees Celsius. So low temperature pressure must be low. If so, then the T2 saturation P2 must be less or greater than 50 kilopascal. The P2, the general concept, not calculating the value, general concept, the P2 should be greater than 50 kilopascal or not. Understand my question?
Greater, sir.
The pressure at temperature 65 degrees Celsius should be high or low in
Higher.
in contrast to 50 kilopascal.
It should be higher.
Yeah, must be higher. That is the tradition of Boyle's and Charles law, or energy follow consideration. So it should be higher. So what will be the diagram, PV diagram now? Before it was down shifting, yeah, from high pressure to low pressure. Now it should be what? Should be like this, from low to high. So I think understand from this two terminal condition how should be temperature impact on pressure, since the specific heat the specific volume is retained constant. Understand my question point? Because we only had discussing with P and V as a hidden terms of temperature T. So in PV coordinate, whenever temperature is rise, pressure must be rise, provided that the specific volume is retained constant. But if the specific volume is also varying, then there is another scenario. It is bit complex situation. Yeah, the both are varying, pressure and specific volume. Then it is no more that on straight line. It should be something different. So now I think we discussed the different function, different strategy about this PVT diagrams of energy flow or heat energy flow. So now heat flow concept TV. Think that previously we discussed two slides based on PV, pressure and specific volume coordinates. Now we are discussing about temperature and specific volume capacity perspective, while pressure is performing crucial role. In TV diagram, pressure is varying, and that will vary the temperature. In case of PV diagram temperature will vary, that will make a change of pressure. So here you can see what you can see here. The same scenario at the beginning of our discussion. The water retained at 250 degrees Celsius or pressure 300 kilopascal, and then the heat energy is actually flowing outward, definitely, because it is 250 degrees, definitely high temperature. So must the heat energy will flow outside, since the boundary is no more isolated from the environment, it is no more adiabatic process. So if so, then the scenario you can represent in such a way. Understand this thing, that at position 1, if we consider it is at 250 degrees Celsius, at position 1 of pressure 300 kilopascal. If we shift from 1 to 2, what is the path? Think that from 1 to 2, it is the whole system is actually vapor phase. Yeah, whole actually vapor phase, because water, this is the mixed phase, this is the solid phase, this is vapor phase. So it is actually transferring from higher vapor stage to lower vapor stage. Why? Because we consider that the heat is flowing from, because from beginning we know that whenever heat flow from high temperature to low temperature, definitely temperature will fall. So once the temperature will fall, it will follow this way. Specific volume also fall, because it is no more vibrant. It is vibrant still, but no more like this, the previous stage. Like stage 1, it is no more like this, because heat energy is flowing outside. So it will move from position 1 to 2. Then what will happen? Once it maintains equilibrium, specific volume, that means it is no more uh, uh, changing the system due to external, because this is the all the vapor stage, saturated vapor stage. It is no more saturated it is actually the transition stage from solid to liquid to vapor phase. So in that phase, actually the specific volume retain constant, it no more sense, it is actually in the stable stage. This is vibrant stage, this is more stable stage, this is semi stable stage. Because once the it is the measure entropy is actually measure of specific volume, because once the specific volume is very very high, it does mean that the molecules are very much vibrant. It actually get huge energy to excited and it to activate for the work done. Because work done, it is actually PV. Yeah, PV is the work done. So in that case, actually it is the most activation area to perform the mechanical work. But whenever you fall the temperature due to radiating the heat from the system towards outward environment, definitely the temperature is falling. And if it is falling, the specific volume also falling. And at that point too, it is actually more stable position, because it is the saturated or the reference level. And here the water retain same, and it is no more changing the volume, so specific volume maintaining constant, but temperature is falling. Why? Because it's supposed to fall the pressure, it's supposed to fall the pressure. Why pressure is falling? Because the, how to say, it is more condensing stage in this level, more volatile stage, the intermediate stage more condensed stage, because this level is more excited than this level, this is reference low level temperature. So once the pressure is decreasing, definitely temperature will decrease. So from 300 kilopascal to 100 kilopascal, if it is the, say, the P1, it is the P3. So say that P1, uh, P2 is actually same as P, and then P3 is actually same as this 100 kilopascal. So definitely, due to losing the temperature, the pressure must decrease. So this is the pressure and temperature relationship. But it is no more like the before stage. Why I think that here it is actually T diagrams and V diagrams. There is a pressure coordinate. It is no. It should be like this 2 to 3, but 2 to 3 is the same phase. But once it is in the one, is the different phase. It is the superheated phase of the vapor. So definitely this stage is more vibrant, more specific volume than that level 2, and level 2 already in stable stage, and that's why no more changing the specific volume, and it is maintaining the similar specific volume with while pressure is losing, definitely temperature will lose. This is the concept of how we can relate the temperature and specific volume in terms of pressure. Now here, this is another scenario. Say two different chamber. Chamber A, its volume is 1 meter cube, temperature 25 degrees Celsius, pressure 500 kilopascal. And its volume B, mass 5 kg, temperature 35 degrees Celsius, pressure 200 kilopascal. So think that the first one is measure of volume, the second one is measure of mass, while the pressure, temperature and pressure is written. So it is actually isolated to tagging a bulb at the middle. These are open system actually, but it locked by a bulb. So once you open the bulb, what will happen? What are the parameter it can be changed to make it equilibrium? You know that equilibrium, yeah? Equilibrium is the more stable state in the world. Anything is want to stay equilibrium. Even we do the actually the semiconductor thing, semiconductor system, our energy system, all actually while maintaining say potential, high potential. What they want to do? They want to flow current and to maintain the same potential from high to low potential to maintain same potential. That's why it flow the electron to maintaining the potential similar. But it is not possible because electron already flowing through the load, it is actually using as work. That's why it continuously maintaining the potential and it continuously doing the work. That is like our house. We are maintaining 30 RMS voltage potential, and it continuously flowing electron to do our work. We are enjoying TV, we are actually enjoying our electric fan or our air conditioning, our mobile, everything actually that due to the maintaining the potential, it's allowed to flow current. Here also some extent it maintaining some variables, that is one is space temperature. Here 35 degree, here is 25 degree. Definitely temperature will merge to make the equilibrium temperature, and then pressure will merge to make it equilibrium pressure. So how we can make it equilibrium? That is the question. Whenever we open the bulb, definitely there will be exchange of air between the high pressure to low pressure area, between the high temperature to low temperature area, then also between the high volume and high mass area. Because volume and mass is different coordinate, but while pressure and temperature is fixed, definitely it can distinguish that it is less than this, while pressure is here higher than this. So think that what will be the B bulb volume, because we need to make something equilibrium. Here is volume, here is mass. So we definitely need to make it volume. So how? Here you know that PV equal to MRT. Yeah? V is here no more specific volume. It is the absolute volume. No more specific volume. So if it is absolute volume, then air mass should be considered. Yeah, and R is the gas constant. You know, it for the pure substance it is fixed, almost fixed for water. So we should find the M1. M1 here is 5 kg. Then the R value is 0.287 kilopascal meter cube per kg Kelvin. It is actually gas constant for ideal gas, say water in the gas here, fluid phase. And then T is actually here 35 degrees Celsius means 308 Kelvin. And how about the pressure? Pressure is 200 Pascal. So the volume should be 2.21 meter cube here. So think that here volume is higher than this. Here is 1 meter cube. Here is 2.21 meter cube. So definitely this volume is higher than this. So what will be here? You can generalize the thing that once the pressure is high, definitely here volume is smaller. Pressure and volume is inversely proportional, while pressure and temperature is directly proportional. So think that here 1 meter cube volume, here is 2.2 meter cube volume. Definitely here pressure should be low, here high, because high volume means low pressure. High, low volume means high pressure. Oppositely, you can say high pressure is low volume, low pressure is high volume. Temperature near about say 10 degrees Celsius, no more significant sense, but it should be also equilibrium. So how? Now the mass for the A we can consider. It is like this, the similar as the equation P V R T1. So we know P is actually at position A is 500 kilo, V is here 1 meter cube, then the R is fixed, then T1 is actually 25 degree means 290 Kelvin. Definitely it is 5.8. So think that here is 5 kg, here is 5.8. That means here more, it is more compressed, but greater mass. So definitely specific volume here should be high or low. At position A, specific volume should be high or low. At chamber A and B, if you compare, specific volume where should be high. Here 2 by 5. Here is 1 by 5. Definitely here specific volume is high. The specific volume high means please revert to the previous discussion. It is more vibrant stage or less vibrant stage. It is more vibrant or volatile stage compared to this, because here specific volume is less than the here. So specific volume high means it is more energetic to flow energy. Definitely it will try to follow to make it equilibrium. And then if you consider the volume and mass in equilibrium, it should be like this. The volume VA and VB should be 3.21, the total equivalent volume. If we don't consider this volume, then it should be the whole volume. And if you consider the whole mass, it should be this. Now we can consider the average specific volume here. Which one is greater, this one or this one? Definitely this one should be higher. So the flow rate must be this way, from B to A. If so, I think understand, you understand it or not? This is the critical thinking level, because here no marking of energy flow. Previously, all the cases you can see there is a marking of energy flow. Here is the outward. Here is definitely inward because it is minus 40. Definitely environment temperature is greater than minus 40 inward. Here also outward. But think that here no more marking about the mass flow or volume flow. But how we can understand? We understand that definitely at position B, the specific volume is greater than in position A. So definitely this part is more vibrant to flow energy from here to here. So if so, then we should consider the total volume and total mass. It is like this. Then we can find the final pressure, because once it will mix together, then the pressure should be make it average or something, the realities of this individual volume. So definitely the final stage mass is total system volume, Mass is 10.4846 kg as we get it here, and the total volume is 3.21 meter cube, and this one is fixed, R fixed for particular medium, say water, it is almost 0.287. Mm. And then the temperature here is 293. Actually temperature we not measure it here, but you can find it, because if you consider this one pbt, here is pbt, then finally you can get the equivalent temperature. It should be like this. So if so, then you will get the final pressure. It should be around this. So think that here neither 500 kilopascal nor 200 kilopascal. It is around 300, 284 kilopascal, around the average total pressure should be. So there definitely mass flow should be from this area to this area. That's why it make balance, and ultimately it will balance on average all this system. I think here the question is to separate volume of indicating specific temperature, pressure, and volume or mass. If we open the bulb to make contact of two different thermodynamic status of gases, what will be the resultant pressure? If the resultant temperature is to actually 20 degrees Celsius, yeah, because 30, you know how we can get the temperature from the mass? Anyone can explain that from mass how we can get temperature? Because how is the definition of heat? Heat actually is nothing but mass, specific heat capacity, and temperature difference. So think that here we can get the mass here 5 kg already, temperature here this. A specific specific heat capacity for air is actually fixed. Say it is constant for both cases. So if so, then the temperature heat exchange from here mass 5 kg, temperature in the final state say uh, final state say T. So T should be, sorry, just wait. Yeah, please. I am in the class. So please tell me very shortly. Yeah, yeah, please. Yeah, madam. Oh, they are asking. They are asking for you from you. Okay, okay. Okay. I will WhatsApp this that previous letter. Yeah, that regarding his sports. Oh, okay, 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 okay. Okay, I'll send it to the, yeah, later. Okay, thank you. Mm. Okay. Sorry, yeah, for interruption. So actually the thing is, you know that there is a mass at position B is 5 kg, temperature 35 degrees Celsius. Here at position A, it already decided that 5.8 kg at temperature 25 degrees Celsius. So definitely the temperature will be in between 35 to 25. Yeah. While mass is here a little bit higher, so you can how can get the energy? The energy should be balanced. Yeah. Energy flow and it will make balance. So the Q1 and Q2 should be equilibrium. If so, then here M and this one should be less. So T minus this 25 degrees Celsius equal m multiply m means 5 kg, 35 minus t. If you make this calculation, because specific heat capacity is fixed, you can cancel both sides. Then ultimately you can find the small t, and in small t should be around 20 degrees Celsius. You can also solve yourself. I think you understand that what I want to say, that mass and temperature difference with specific heat capacity multiplication will get the amount of heat energy. Here also the mass of the air and its temperature difference and specific heat capacity will get the heat amount of heat. So here actually the specific heat capacity fixed, so we can get the resultant temperature by calculating both side equal, and it will ultimately it should be around 20 degrees Celsius. So that is the equilibrium temperature we get. And then if so, then ultimately we can find the final equilibrium pressure, and that is around 284 kilopascal. So this is the simple understanding that how we can measure the undefined thing of these PVT diagrams or PVT coordinates by simplifying the relationship of heat flow, energy flow, or some extent the real theoretical concept of thermodynamics that we already discussed here. Before we discuss separately that, okay, I show you once again. Before we did it separately like this, that that high temperature situation, how it energy flow and how it make the pressure equilibrium to flow pressure from high to low, while the temperature is also maintaining from high to low. And the second case is low temperature environment, so heat must be flow inward and ultimately raise the temperature. If so, then the pressure should be hot, and ultimately the pressure will rise from 1 to 2. And then we discussed about the temperature effect on pressure. So if so, then the high temperature situation of the vapor, water vapor, so it definitely you lose the energy to the environment, and if so, then it will transfer from saturated level to the sorry um, uh, the fluid sorry the vapor level to saturated saturation level of mixture of solid sorry liquid and vapor. Because it is transferring energy or losing energy, definitely temperature will fall. And once it is maintained the equilibrium, then actually it maintain the specific volume, and finally due to the variation of pressure, it must fall the temperature. But that means the concept is here, low pressure will pay temperature will be low. Previously the concept is uh, high temperature pressure must be high. So temperature and pressure relationship is like this. If so, the specific volume is maintained constant. That is here 2 to 1 is maintaining constant. That is here 1 to 2 is maintaining the constant of a specific volume. Now the third situation is the mixture of the combination of thermodynamic status. First we need to find the volume, the unknown volume of the second stage. Then we have to measure the unknown mass of the first stage. Then we can mix together. Once we mix the mass and temperature, definitely there will be resultant temperature, and maintaining the resultant temperature we can get the resultant pressure. So this is a very simple very fundamental analysis of heat energy flow through the pure substance. Pure substance here is the water vapor or water itself. It has certainly specific volume, it has certainly density, specific density, it has certainly the specific temperature, pressure, everything that will vary with the third variable. Say whenever it is PV diagram, then temperature influencing to make variation of pressure. Whenever it is TB diagram, then pressure make it variation of temperature. And that is the scenario, that pressure and temperature coordinates how the volume or mass play around to maintain the equilibrium of the system. I think that's all from my lecture today or my tutorial, whatever you intend to learn. And I think if you want, we can go now towards the attendance part. Before that, I should uh, uh, stop
Uh,
the recording. Yeah, please.
will the